Okay, good evening, welcome to
FamilyMath578.
FamilyMath578. So this might be a tricky one, because you watched the video about an hour and a half ago, but we're talking about Grant Sanderson's derivative movie. So, had you ever heard the word derivative before?
No, I
No.
haven't.
No, and I would have been surprised if you had heard it before, because it's a concept from calculus. And you haven't seen calculus, but Grant Sanderson's doing this amazing series, so it's kind of fun to watch. What are some things you remember from the movie?
Well, he looked at, there was this problem about a car that was driving.
Yeah, the problem about the car.
And the paradox that resulted from it.
Okay, well let's talk about those two things separately. What was the car doing?
Well, the car was just driving from one point to another, and it picked up speed, and then it reached a point, and then it decreased in speed, and then it stopped again.
Okay, good. Yeah, so the car was moving, and it was moving in a very specific way.
Yeah.
Yeah, we'll talk about that in the next video. And then you said there was a paradox. What was the paradox?
So that, like, at the t equals, so like the time, when time equals 0, the car's not moving. But when does the car start moving?
Yeah. So that was a specific example. I think the car there was moving a distance t cubed at any given time t, and he found the derivative, which is sometimes referred to as an instantaneous rate of change, and he was explaining that that's not necessarily the best way to think about it. And he gave this paradox that at t equals 0, if you thought about instantaneous rate of change, the car was not moving.
Mm-hmm.
And then the question exactly is what you said, well, when did it start moving then? I'm just curious, do you think the car was moving at time 0?
Well, it's hard to tell because the equation would have involved dividing by 0.
Ooh, yeah, that's a problem. What do you think?
No, I think it was.
You think it was?
Because that's like the only way that you could really solve this paradox, is if it was moving at t equals 0.
I mean,
Okay.
we know it's moving after t equals 0.
Yeah. All right, cool. Give me one other thing you remember from the movie.
Well, like about, like the rise over run sort of approximation for this line that was sort of eventually supposed to be tangent.
Yeah.
That's sort of how you got this equation.
So he was looking at, and he called that d, what do you call it, dx?
dx and tx.
Dy maybe? So we had a curve, and then we zoomed in, and we asked for a small change in x. Let's look at the small change in y.
Okay.
And that was helping us find approximately how fast the car was moving. And this is a general idea that you study in calculus. When you move or you perturb or you just make one sort of tiny little step forward, how does that affect the output of a function? Or how does that, if the distance, if time goes just a little bit forward, how much further distance do you go? If you're going slow, you might go a small distance forward. If you're going fast, what might happen?
You might go a larger distance.
Yeah, you might go a larger distance forward. Okay, well, let's talk about some of these things.
Okay.